Hello, my name is Xenophon Papadimitris. I'm a professor in radiology and biomedical imaging and biomedical engineering at Yale. This interview is part of a collection of conversations with experts in medical software from academia, industry, and regulatory agencies, and is supplementary material for a Coursera class Introduction to Medical Software that will appear in the fall of 2021. Our guest today is Rajesh Venkataraman. Rajesh has been at Eigen since June of 2011, where he leads the R&D efforts. He has about 10 years of experience in developing software and hardware for medical devices and working with regulatory bodies like the FDA and European Union regulators as well. So Rajesh, with that, welcome. It's good to see you.
Thank you,
if you could
Xenios.
start by telling us a little bit more about you and Eigen, what you guys do, and then we'll get on from there.
Definitely. Once again, thank you for this, inviting me for this interview. So the main thing is that at Eigen, we have a medical device for prostate cancer diagnosis. We call it precision diagnosis, which includes a software and a hardware component where we assist the doctors, urologists, and radiologists in mapping out the prostate and figuring out where in the prostate do the urologists need to biopsy so that they can then know with high certainty whether that person has cancer or not. So my role in the company is I lead the research and development efforts out there, and I have been working with this product since its infancy, since we got clearance in 2011.
So when we talked last night briefly, just to set up this interview, we have a number of topics that we're going to walk through, mostly on software engineering in the medical device space. So we're going to start. The first one I want to touch base with you, and this is something you brought to my attention, it's an important topic actually a while back, is the whole issue of usability. And what does this involve? And you had mentioned to me about, you have different level of users, really expert users, less expert users, and you have to design a device for all of those in mind. So let's just hear a little bit more about what that process is.
Definitely. It's a really hot topic in today's field, especially with the new regulations that are coming out, is that they are all focusing on how are we improving the software's usability. I think in today's world, everything is driven by software. And I have this really cool thing that when I joined the company, we had this expansive software that was developed with the key opinion leaders from the different universities in mind. Now, these are all really smart people. So when you train them to say, what you're doing segmentation, we are doing some kind of elastic deformation, they can understand the terminology. But then when you go on to the second tier and third tier centers, which are still doctors, but they don't work with engineers day in and day out, they struggle to understand what you mean by simple terminologies for an engineer, like segmentation, like deformation. They're like, what is it? What are you wanting me to do? And we found that early on, training such doctors becomes a challenge. When you say, click this button out here and then do some process out here, then click some other button towards the top, they forget it. These are doctors who utilize the device maybe once a week or maybe 2 times or 3 times a week. And they have so many different devices that they deal with that as engineers, we do not think about what they go through in their daily lives. So when you start thinking about that, you understand why usability becomes such a big deal. And we had a big paradigm shift at Eigen, starting around 2014, 2015, where we decided, everything is going to be like a wizard. You just click one button, training becomes easier. Just do something on the image, click on next. Do something, click on next. So in that way, it simplifies the process for the doctor. In one case, you can train them. All you have to say is do something next, do something next. And that really led us to develop a software that really streamlines the workflow for a urologist. And this is very critical for a procedure-based software like the Artemis device, which is used for prostate biopsies. You need to make sure that you guide them through the process, what needs to be done next, next, and next, so that they can then have a really accurate and a precision diagnostics in this case.
I see a lot of studies, done at these major academic centers, and they claim accuracy and things, and I always wonder, this is in the hands of the best possible user, right? So how will that translate? And that's the issue we're dealing with. So
exactly.
let's move a little bit from there, but I think it bleeds into the next topic. We're going to talk about software architecture, documentation, maintainability. But in some ways, you already touched on one aspect, which is designing the architecture to enable this workflow setup as well. Right? The user isn't doing arbitrary. This is not Microsoft Word where the user system is there and you click buttons and you can do any operation in any order. You're designing something to enable somebody to do a task effectively. And that's where the workflows come. But let's talk a little bit about software architecture, how you document this, how do you design software architecture, how do you make modular, how do you make it maintainable, and all the things that you guys do.
Definitely. Yeah, and this is something that I've seen a lot of young coders or developers who come out of universities or software engineers, is that they understand how to write their own code, but what they struggle understanding is how do you fit yourself into an existing framework, into an existing architecture, right? So the big thing I tell them is, look, don't try to understand all pieces of the code and then try to solve the problem. Understand the piece of code that you're working around. Make sure that the first thing you do is write small pieces of code, like small functions. Understand how the whole thing functions. Instead of you coming up with a solution saying, you know what, this thing does not work. I want to develop something that goes from A to B in a roundabout fashion. And instead of understanding how the current route works and then how you can fit the pieces in place, so it really is an efficient solution. So that experience led me to believe that, you know what, the biggest problem with any code that we have that's been there in the field is documentation. And you have the problem of legacy code, people trying to read somebody else's code. And in my experience at Eigen, I have found that comments are about 70% or less than 70% accurate. And if it's a really old legacy code, you don't even believe the comments anymore. You basically say, hey, don't, I mean, I had developers come and tell me, don't read the comments. They don't make sense. Then I'm like, how do I read? How do I understand this code? So what you need to do is you basically need to work on breaking down into different modules. And my first task coming to Eigen was they gave me this big software and they said that, hey, we need an architecture document for this. Develop an architecture document so that we can then submit to the FDA. And I was lost. I didn't know how to begin with. What do you do? Where do you go? And I had to read a lot on how do you create architecture documents? What are the different areas you look at? But that helped me a lot. That helped me understand that, you know what, software, if you don't understand, it's a complex mechanism. But once you start understanding what you want to do, it becomes very simple. And what I mean by that is that you want to take a big project and break it down into smaller chunks. If you're not able to break down to smaller chunks, then talk to somebody. Talk to somebody in your company who understands the code so that you can then break it down into smaller chunks. That's what we call as modules, right? So understand where the big pieces of the puzzle are, create a flow chart around the big piece, and then go down to each piece and see whether you can make it self-sufficient. If a particular module becomes self-sufficient and its interaction with the outside world is minimized in the code, then you're going to have a really stable software moving forward. And we had that experience when we're developing the Artemis code. Which is going to basically, we have a hardware device. And initially, when I was working at Eigen, it was really cumbersome to develop on Artemis because you needed to go to the device and then start working on the device, and then there were people sharing it. So if there were two people already using it, I had to wait for my turn. So I had to see that, okay, when I'm going to finish and then come back and then do that. So what we decided was, okay, let's develop what we call as a simulator where we're going to modularize it. The interaction with the hardware is going to be a separate module. We pick that to be separate. And then we make sure that all the other pieces of the code, like we have a segmentation module, a registration module, all those things are independent of the hardware. So now we can sit up on our own desk and develop on the simulator. And we are with confidence, we can know that when the testing happens on the actual device, it will work. So now you have simultaneous development. And it's a very critical factor when you're trying to architecture a device. You want to make sure you break it down to small modules. That's number one. And two is each module is self-sufficient, which with the ability to minimally interact with the outside world.
Let's talk about testing a little bit, since we're jumping over to that topic, which is fine. I mean, you already touched on the idea of a simulator, which is a very powerful tool for abstracting hardware out. But let's talk a little bit about how you, I mean, and this is the key test for testing in this mixed hardware software setup.
Mm-hmm.
How detailed are those simulators? Are they just generating a data stream? How variable are they? What does it involve? And as much as you can say, obviously, I don't want you to tell me all the
Definitely,
details.
yeah. True, I understand that. So the biggest thing about a simulator is you need to see what is required to do your development, right? I mean, in our case, our hardware, we have a robotic system. So the interaction with the hardware is a limiting factor where we want to be able to develop the remaining pieces of software without actually working on the hardware. So for us, the simulator basically involves how do you simulate the inputs of the hardware using standard inputs like the keyboard or the mouse? Can we utilize those items to actually simulate what an actual hardware would do? So that led us to say that, you know what, we can use our keys, keyboard keys, special shortcut keys, and all those special tools that we can develop that simulates what the actual hardware would do. And when you're able to break down the software into those type of modularity with hardware specific functionality, simulator specific functionality, and it joins in the same place in the code, then it makes it easier to switch between a simulator and the actual hardware or the actual firmware of the device. So in that way, you can then sit at a workstation, sit remotely anywhere, and then develop on the software, keeping in mind that you can use your keystrokes or you can use your mouse or a joystick to actually simulate what the actual hardware would do. And that becomes a critical piece. This is a very critical piece if you have, or if you're working in a medical device that actually has a hardware component to it. If you're working on a software component, this simulator doesn't make sense. You have the software, you don't need anything special, so you just develop the software. But only when you have a hardware piece, having the simulator really speeds up development, maybe about 5x or 6x times than actually having a device and not having a simulator. I can say from my experience that when I joined Eigen, developing on Artemis was time consuming. If you had a simple GUI change, it used to take 1 week to make sure that the GUI was changed and then it doesn't affect anything else. So that's how integrated the code was between GUI and the models. But then over time, nowadays, if you want to change a GUI, it's going to take us probably about a couple of days. We have the GUI changed, tested, everything done, and we can release the software pretty fast.
Although, to be fair, simulators also come into the picture when you're dealing with external systems. And we're going to talk maybe a little bit about standards like DICOM and HL7, but your software has to integrate with electronic health records in the hospital, with the DICOM database. Do you use simulators for those too? Is that part of how you test, or do you have systems like that set up?
No, definitely. I mean, in today's world, everything is available for you. So, for example, if you talk about DICOM, you have a lot of these DICOM tools that are like PACS systems, which is the most critical component for a DICOM. So if you're able to run a PACS on one of your virtual servers, then you have what you need to interact with the PACS server, keeping in mind that the DICOM conformance of every system is different. The term conformance is loosely defined out here. So in DICOM world, from my experience, I've found that just because somebody's DICOM conformant doesn't mean that they follow the standard to the T. You could have a huge variation between two different devices, even though the conformance statement says, yes, I support this particular DICOM class. And so at that point, the best way to deal with this, work with the client and then deal with trying to figure out what's the problem with that. So that's a good point you brought up, that for DICOM, you can have simulators you can run. HL7 is even more simpler in terms of simulators, but more complex in terms of implementation, more complex in terms of real life workflow, because it's difficult to simulate a real life workflow unless you spend effort in developing a simulator for HL7 that throws out messages pretty fast to simulate how a hospital effect would be there, how a clinical effect would be there, how a procedural effect would be there based on HL7. So each one has its own unique items that need to be considered when you're developing the simulator, and it's a critical point in development. Without a good simulator, you're going to spend a lot of time after the release of the software in trying to resolve the issues. But you can't spend too much time on a simulator because you won't get your features out. So it's a trade-off as to how good you want your simulator to mimic real life to how fast do you want to build features and release that into the market. And each company would have its own variation of that.
Okay. So the last thing I want to talk about on the software development side here, we had talked when we were planning this, you have the Artemis system, which is a class 2 device. It's basically a diagnostic device. It has a certain level of coding, a certain level of testing. I know you're working on a class 3 type approach now where you're getting more into the therapy world. How does that change the software development? How much does it change the testing setup? What is, at the high level, the impact on your process as we move to a higher risk level device here?
Definitely, that's very critical for us. I mean, in Eigen, currently, we are in that process of moving from a class 2, as I said, for the Artemis, to a class 3. We are looking to support therapeutics. And so for that, you need to plan ahead of time. So the way we approach our code is that we first design to say what is our ultimate goal. And then based on where we stand, we work towards that during every release. So if there are certain pieces of code that are really complex and are difficult to understand, we start first by understanding what the complexities are, whether that complexity is essential. And this is just a discussion with the developers or a group of developers. You just discuss that. And then you say, hey, you know what? We want to get to this location, final design for therapeutics. We know that we're going to have this level of scrutiny on our code. So if you want to get to that particular destination, you then say, you know what, my design is currently here. This is the point I want to reach. How do I break down the different components of it so that during every release, I move towards that? So that in 6 months' time, my code that began from location A is now more towards a class 3 type of testing, which will help me to smoothen the regulatory process. Instead of us then decide, the flip side to that is, okay, you just continue developing for this, and then suddenly the management comes back saying, hey, we're going to develop a class 3 device. I want to integrate with a class 3 device. So then what I'm going to be doing is spending about 6 months to a year just on your current software to get to the same current state that you currently are, and with no new development or anything, but reworking the architecture, reworking everything so that you can now pass for a class 3. And the biggest thing between a class 2 and a class 3 device is the ability to test, is the unit testing, is the integration testing. So you want to be able to develop your tools slowly over time so that you reach towards a class 3. And in my experience, I've always found that you talk to the developer, say, hey, you know what? These are the levels of scrutiny that we need to pass if we want to be a class 3 device, work on a design, and then start implementing them over time instead of just going one shot in and spending 6 months just trying to implement it. It's never a 6 months. So if you have a time frame from a developer, it's always going to be more than twice that. That's been my experience.
Yeah. No, I guess just for people listening, especially for students, what's implied here is, of course, that the two devices have significant shared code base, right? You're working on the same products. So, and as you move to class 3, you probably need a more detailed design and more detailed levels of testing, which requires smaller modules effectively and easier to digest modules. I guess that's what you are alluding to. So
that's correct, yeah.
Yeah. So one other issue that we had talked about was this concept of internationalization. So you are producing a device in the United States, and we think, okay, English, although the moment you leave the United States, there's a million other languages, and some of them are not Western languages in their scripts. How do you take a piece of software that's designed in the United States? First of all, how do you design in such a way that it's easy to internationalize? And so what does this process look like in practice? How does the translation happen? How does the implementation of that happen?
It's a really good question. And we have had, or I have had nice experience with internationalization. We began with the software that was developed in a university. And that went through the churns of industry, and we came to a decision at that point. This is probably in 2008, 2009, that at that point they decided, hey, let's not worry about internationalization. We are going to sell this product only in the United States. It's going to be every person is going to use it. And at that point, the ambition was pretty high that it's going to be about 100,000 devices going to be sold in US. And so they didn't think about, okay, what happens if we go to Europe or for Asia or the different places. So then in 2014, there was a shift in paradigm at Eigen where they were like, you know what? Not only are we going to be selling in US, we're going to be start selling in Europe, in Asia. And that's when the biggest thing came into is like the first question that any doctors from Europe are going to ask is, does it support German? Does it support French? Does it support Swedish? These were the languages that they were asking initially. I mean, depending on from which region you are in Europe. And we were like, not at this point. We don't have that kind of support. So how do we move forward? And that led me to work with my developer who was really experienced. And we researched a lot of topics and we found that, okay, you need to have your code structured in certain ways. You need to develop your framework in such a way that you can extract all the different strings out of it. So the biggest thing about internationalization, it's not a complex topic. So as students, when we talk about that, don't think of it as a complex topic. It is just a design paradigm. If we had an idea to begin with that we are going to be doing, we're going to be selling in different products or in different countries with different languages, we would have designed the system in that phase to begin with. And the biggest thing about English and other language is the string which stores the data. If you have the ability, or if your platform or your development environment has the ability to extract these strings and list them out as a table or as a list, then it makes it easier for internationalization. So what you would do is you would work with the translator. You would provide them either the GUI mockup, or you would provide them the list of words that need to be converted to a particular language. They would start working and converting all of those things. Then you would just take that file, put it into the software, and then basically see how it converts. Send that to a doctor, because there's a big difference between getting a translator working on translating the words and the doctor and the nurses who are actually using it, because the terminologies could be way different between the two. So you then give it to the doctor for feedback to say, hey, do these words make sense? Because you might not know French, you might not know German. And then they come back saying, hey, these words don't make any sense. I don't know what this you're talking about. And that's the back and forth process. And this would be simplified if, when you design a software from scratch, you keep in mind that you want to expand to different languages, you want to expand to different countries. And in today's world, I think most of the software are developed for the world. There is no concept of this is going to be just for US, this is going to be just for Europe. 95% of the products in my experience are developed for different, are single development, but are developed for different markets, in the sense that a single product will be sold in different markets. And so every software you're going to come out into the medical field will have this notion that you want to internationalize. So all young students out there, the best thing to do is design with that in mind. Keep in mind that my software is going to be sold not only in US in English, but could be sold in Sweden, could be sold in Norway with different languages. And keep that in mind when you're developing software to begin with, because it'll make your life really smooth when the marketing person comes and says, hey, I want to sell this in Norway, there's a big demand for it, and you don't have to worry about it. Just say, yeah, no problem, I know what you're talking about, just give this file to a translator and he'll take care of it for you.
The other hot topic here is cybersecurity. You can't fail to see the news and not see an incident after incident. We had an incident at Yale with radiation therapy not too long ago, and I'm sure you have seen lots of them. What are the challenges that you see as somebody who designs devices? And we had talked about how, if you see the guidance, they talk a lot about encryption and authentication, and the protocols that we depend on, HL7 and DICOM, have neither authentication, not for the real world, not much encryption. Maybe HL7 has a little bit of encryption now. What are the challenges with cybersecurity and how do you design for that, especially with devices that are touching humans in real time?
Yeah. So one of the big pushes from the FDA and even every regulatory body since the different incidents that have happened recently, and especially since COVID time, has been cybersecurity. There's a big section in the FDA that asks about, have you considered different cybersecurity features? Does your risk analysis, which is the crux of any regulatory body document, does it talk about what are the different cybersecurity risks that your software goes through? So have you thought about every consideration? Have you thought about stuff like, okay, what if somebody hacks into your system? Can they get at the patient data? What if somebody hacks into your device? Can they get at the data at rest? So all these type of questions are asked in cybersecurity, and it's a big shift. The way I think about it is that there are two levels to it. You need to understand what is the environment your product works in, right? And we need to understand whether your product is a software product or a software plus hardware product, because the cybersecurity for those are significantly different. If you have a software product, you are going to be installing on a system that's already behind a firewall. Like you're going to be installing it on, for example, we have this Profuse product, which is a radiology solution, which is a software only solution for radiologists that is installed on PACS workstations that are behind a firewall, that are behind the security of a site, and it doesn't interact with the outside world. It just interacts with standard DICOM PACS systems. And with that said, your security requirements are not that extensive, because you can leverage the fact that each site are going to have their own security constraints, and it's going to basically add on to your product. So that's one part of it. The second part of when you have a hardware is the biggest question they're going to ask is it encrypted? So what they mean by that is you have a hardware device, you store the data on that. If there is patient data, if somebody comes and steals your device or steals the hard drive or steals the place where it stores the data, can they have access at it? So that's one of the questions they ask. So in terms of hardware, you need to have basic stuff like encryption. You need to let them know that, hey, not everybody can access the system. You need to provide them with a username and password. And the funny thing is username and password, even though we have the security system, they are only as strong as your weakest password. So it depends on who has the weakest password in the system and they can get into your system. So you are bound by what the site can provide you in terms of cybersecurity. But the main push by the FDA is not about the site, it's about your device. So they would ask, have you considered those problems? What is your solution for that? And you need to make sure that you understand what are the limitations on which direction they're coming for. Because as developers, we don't think as to, hey, why do I have to care about security? Why do I have to care about patient data? It's at the site. They need to care about it. It's not my concern to worry about it. It's the site's concern. It's the hospital's concern to protect their data. But what the FDA and everybody are trying to let everybody know is that there should be some level of responsibility as medical device manufacturers that you help in that process. Do you add on to the existing security to the hospital? So you make it difficult. You make it really impossible for a hacker to do that. And this is a simplistic thing for devices that are just internal to a site. And you have a whole level of complexity if you're going to a cloud solution. And I think everybody's still trying to figure out what is the most efficient way to do it. You have the recent cloud ad that came out, right, in Europe. It talks about that the data for any patient living in a particular country should not leave that country. It might have the best encryption in the world, but it cannot leave the country. And so we had to modify a software which has a cloud component to it to make sure that any patient data resides in that particular country. Like, for example, in Switzerland, it needs to be in Switzerland. Germany, it needs to be in Germany. So now we are dependent on these different cloud providers like AWS or Microsoft or Google to basically have data centers in these different locations. And then we use those data centers to store data. So these are all factors that you would consider when you're developing the software, knowing your market. If you find it difficult to know your market, then you talk to the marketing people, you talk to the regulatory people and figure out what is the end goal? Where is my product going to be used? And that drives up the level of security that your system is going to run. And that makes it really big. And it's really good to design that early on. Then later on in the game, when you find that, you know what, I need to redesign my architecture because this is not going to work.
Yeah, I mean, that seems to be the common thread of all medical software. Think about it early, because if you discover late, it's a pain to deal with. I have two more topics, Rajesh. We were going to talk a little bit about machine learning. Maybe we'll save that for the end. You had some thoughts about revision control and programming and how you can use a revision control system to actually learn how to code in some ways and to code review. So let's talk a little bit about that. How would one use source code management, not only to manage code, but also as a training tool for new people as they join a company, as they get used to the industrial environment as opposed to, say, the university environment? Yeah.
No, definitely. I mean, so that's the biggest thing that I learned from. So my experience in coding was very minimal when I joined Eigen. In fact, I tell people that when I tell people who come in and who has worked with C++, I say I had no C++ experience when I joined Eigen. But you put in the effort, and what I found is that at that point, we just started using Git. So at Eigen, we use Git as a source control. You need to know your tools. It doesn't matter whether it's Git or whether it's SCM or whether it's Helix source control. It doesn't matter. You need to know your tools. And every source control out in the market has these tools. What you want to do is when you have a particular problem and you fix it, the first thing I always used to do when I was initially developing is work with an experienced developer and do a code review. That's number one. Now, the problem in code review is that the experienced developer doesn't know what is the code that you have added. So he finds it difficult to know whether there are about 100 lines of codes, and he doesn't know which are the segments that you have added to fix a particular problem. But with a source control, what you can do is you then look at the differences between two different, in Git terminology, you look at two different commits. You look at the differences between the two commits, and then you basically see what lines of code have you added from the existing one. And that gives the experienced developer an idea on what you are trying to do. And he would basically let you know, hey, this style is not going to work out because of X, Y, and Z reason. So instead of that, look at the way I did it in this particular area of the code, and you can do that. So, and then the second biggest thing is that if you are going to look to see, okay, there are some issues that happen, there's a bug that happened, and you found that this particular line of code was a reason that particular issue happened, you can then trace it back to see who was the person who actually implemented that code. And you can see the chain in which the code was implemented. You can see the origin of it, and then you can talk to the developer to say, hey, this line of code is causing this issue. What was the reason for you adding it? So the whole thing about code development in my mind is basically to understand the paradigm in which you're coding. So, and Git in my case really helped me a lot to see as to what are the differences between what I developed and what somebody else developed, and then to change the way I code so that it's very efficient. I really believe that if you have issues in your software and you can solve it in 2 lines instead of solving it in 15 or 20 lines, the 2-line code would be more effective than the 15, 20-line code. It cannot be generalized, but in my experience, when the issues are there, I've always found that just by doing minimal changes, if you're able to fix an issue, that means that you haven't drastically altered the architecture or the flow of the software, which basically makes the fix more stable, more reliable, and you are confident in understanding the paradigm better.
Okay. So let's end on with a brief discussion of this whole world of AI and machine learning and how it's affecting devices. And obviously, there's a lot of hype. You sitting in industry see lots of publications, some of which you trust, many of them I trust you don't trust. Mm-hmm. How do you proceed? How are you adopting this technology at this point?
It's an interesting question because as you need to wear different hats for that, right? As a marketing person, you want to catch on to the wave of ML and machine learning. And I mean, even in the marketing world, nobody wants to use the word machine learning, where 90% of all people who say AI are actually machine learning tools. They are not true artificial intelligence where you have the training and everything done on the system. You just have them predict something based on an existing model you trained in a controlled environment, right? So in my mind, most of it is just machine learning and not AI. So when you talk to a marketing person, it's like, hey, what do you have for AI? What do you do? Can all these things be automated? And they come and push back saying, you need to implement all of this in machine learning. It is a difficult push at this point because you see almost every company come out with the word saying AI driven or AI powered, or we have AI in our software. And it's difficult to explain to a person who's not well versed in the art to say, hey, don't worry about it. It's just a wave. We can put that wave in there by having certain components of machine learning in it and call it AI. Uh, so that's on the marketing front. As an engineer, right, the biggest thing you need to understand is machine learning, or what I understood basically from this is machine learning is not for everything. You can't just build a system to say, I want to go from point A to point B, I'm going to build a machine learning system. The amount of effort it takes to build that, it's like, you know what, I'll just do a standard software engineering and figure out how I can resolve the problem and fix it. That should be good enough. The biggest case in point for me is the segmentation problem. So we have segmentations for doing the prostate in both MRI and ultrasound. And we have a lot of machine learning algorithms that are available in the field. And there are a lot of papers that have come out that talks about machine learning for doing prostate segmentation and for doing ultrasound segmentation. And they're open source. You can easily avail them and use them. But we found that you bring a couple of algorithms and you try it out, you have your own data set, you run it. If your 50% prediction is as good as 50%, you are lucky. And that's what we found, that, you know what, I don't think I can use anybody's algorithm that easily. There might be thousands of algorithms out there. Not all of them are translatable to a real world situation. So you need to understand where machine learning would help you. There are only certain tasks in your software or in your workflow that machine learning can be helpful. And I always think as an augmenting tool. And I always do this. I do this cost benefit analysis. What is the amount of effort that's going to change if I have machine learning? So if the doctor has to click 5 times to create a segmentation versus having to click 0 times in segmentation, but then he has to do a lot more refinement, it's not a good tool. At the end of the day, doctor spends more time using the machine learned result than having to develop the software that you develop from scratch. So I always see the trade-off between cost benefit analysis, between whether it's worth the effort to go towards machine learning for certain problems, whereas not that much for other problems. And it's a hot topic in today's world. I think my opinion might not be that popular. Everything today is going to be like, people are going to say, hey, machine learning is there for everything. Everything we want to do can be machine learned and can be developed. But I still think you have the big problem of training data, the big problem of it being a true black box where nobody understands when things work, they work really well. But when things fail, why did things fail? How do things fail? And I really believe you need to know your bounding box. You need to know where your algorithm works really well. And if you don't know that, then you do not have a good, stable solution in the field.
Thanks, Rajesh. So before we close, I guess the last question I ask everybody is there anything else you wanted to bring up that I failed to ask, or do you have any advice to students who are looking to get into this field based on what you have seen?
Well, definitely. I mean, I have worked with a lot of bright young minds who come to Eigen, and the first thing I always tell them is, don't be scared of asking questions. It doesn't matter who the person is. The more you ask questions is when you would start understanding and learning. And I have found that students or people who are very upfront about asking questions, not worrying about whether it's a simple question or a complex question, and just being more upfront about it, saying, hey, this is what I did. Do you think this is correct? This is what I did. So what happens is that it reinforces in you that the direction you are going is in the right direction. And that will be my biggest advice to all young coders out there or young developers and engineers who start working in the industry, is to be open, be more forthcoming with your manager or with your immediate boss to say, hey, this is what I'm doing. It may be a daily update. Just go to him and say, I did this today and I was struggling with this. Do you think I'm going the right direction? I did this thing today. Do you think it's the right direction? So what happens is in 6 months time, one thing is you're going to develop the rapport with your immediate superior, and he or she starts believing in you that, you know what, you give him a task, he knows how to get it done. He understands how the software works, and he's basically able to get stuff done. So that would be my big advice. Communicate, ask questions, and understand what you're trying to develop. You need to understand each and every word you put in your software. And if I ask you, why did you use this for loop, you should be able to explain why.
Okay, thanks, Rajesh. Thank you for coming on. Thanks for the advice.
Thank you very much, Zenius. Really appreciate the opportunity, and all the best to all the students in the class.